Okay, so part 2 of this paper, we are looking at the volume of this prism. Now the volume of a prism is the area of the cross-section times by the length, and the cross-section is this area here at the end, this area here. Okay, so the way I would recommend that we do this is let's draw that area out and then start from there. So we've got this sort of L-shape area, and there's often a mark for just doing this much, just splitting that up into two rectangles. So this one's A and this one's B, and if we just say that one's 4, that one's 7, that length there is 5, all the way across the bottom, look, is 11 centimetres. So that means that this distance here is 11, take away 5, which is 6. So if we get that far, there's often a mark for just doing that bit. If we want to find area, the area of this rectangle here, so we write area that we've labelled A is 5 times 7, that's 35 centimetres squared. The area that we've labelled B is 4 times 6, which is 24 centimetres squared. And so the cross-section area, that's all of this all together, is 35 plus 24, which is 59 centimetres squared. And then, remember what we've just said, the volume of a prism is the area of the cross-section times by the length. So that is volume is 59 times 20. And that equals, well, let me see, 59 times 10 is 590. 590 times 2 is 1,180, I think, but it's a calculator paper, so we can just check that. 590 times 20. Oh, I did make a mistake. 11,800. I got my decimal point in the wrong place. So 11,800 centimetres squared. There we go. For that one. Now, the thing to watch out for these is that this asks us for the volume. If it asks you for the volume, don't find the surface area. If it asks you for the surface area, don't find the volume. So the volume of a prism is the area of the cross-section times by the length. The surface area for any shape, any 3D shape, is find the areas of all the faces and add them together separately. So that's this question was asking us for volume. Okay, this one here. So describe fully the single transformation that maps shape P triangle P onto triangle Q, and the key with these is it does say single. With a lot of these, people have been saying, well, if you do this translation and then this rotation, it works. But in for all of these questions, they will ask for a single transformation, so just one. So that has to be the transformations that we know of are reflections. Well, let's just check. Does this look like a reflection? Well, it doesn't look like shape P has been flipped in any line, does it? So it's not a reflection. Is it a rotation? That's the next one. Well, again, shape P has not been rotated round. And the other two are translations and enlargements. Well, we said it's not a reflection, it's not a rotation. Shape Q and shape P are exactly the same size, so it's not an enlargement. So that leaves us with a translation. And a translation, if you remember, SL for zlation and SL for slide. So it's a slide from triangle P onto triangle Q. So we need to say it's a translation. And you might think this is nice and easy. It's 2 marks, and we just have to say it's a translation to say how we've slid it. But the way we have to say that is we have to give them a vector. And the vector, if you remember, is 2 numbers in the brackets, and the top number tells us how far left and right we've gone. So if we take this corner as an example, we've gone 1, 2, 3, 4, 5, 6 squares to the right, so that's a positive 6 just there, and then 1 square down, so a negative 1 just there. If we'd moved left instead of right, then this would be a negative number, and if we moved up instead of down, this would be a positive number. Okay, so the top number is left and right, the bottom number is up and down. Positive is right and up, negative is left and down. Okay, so the way you think about it is look on the x-axis. Look, the positive numbers are across to the right, the negative numbers are across to the left. The positive numbers are up, the negative numbers are down. So as long as you remember that the left and right number comes first, and that shouldn't be too difficult to remember because it's the same as coordinates, isn't it? along the corridor, then up the stairs, as a lot of people remember. Okay, so translation. Now, if we write this, just translation, and this, then that's fine, but it would be best to say translation by the vector 6 minus 1. But for 2 marks, they're looking for 1 mark the word translation, 2 marks 6, 1. Oh, now, I'm not sure that's quite right, actually. I think they're looking for this vector for 2 marks. I think translation on its own may not get you a mark at all, I'm afraid. So watch out, make sure you've got those vectors drawn out properly. Okay, expand and simplify. So we're expanding these brackets. 3 times x is 3x. 3 times a positive 4, excuse me, let's just rub that out. 3 times a positive 4 is a positive 12. Oh, sorry, this is my hand resting on the iPad and causing us problems. Here we go. Plus 12. Then we've got 2 times 5x is 2 times 5 is 10 times x. And then 2 times minus 1 is minus 2. And then we've got a plus sign here, so we've got 3x plus 12 plus 10x minus 2. That's got us so far to 1 mark out of 2. What we need to do now is simplify this so we can collect together the x's. We've got 3x's and 10x's. That gives us 13x's. We've got 12x's. We've got 12 minus 2. So we have 10. So our final answer, 13x plus 10. Okay, the next one, expand and simplify with this. Well, this is one of those things that we haven't done in lessons officially, but we have done in the several revision sessions, and a lot of people ask me about it, and it is on the top 40, so you may well have looked it up. So it's got a dotted line around it here, and we do 2x times x. Well, that's 2 times x, so it's 2 times x squared. 2x times minus 4, so that's 2 times 4 is 8, positive times a negative is a negative, and there's an x on there. 2x times, oh sorry, we've done 2x times, it's 1 times x is x, and 1 times minus 4 is minus 4, and then we can collect these two together in the middle, so 2x squared minus 7x minus 4, if you think about it, minus 8x plus an x is minus 7x. You've got to remember that you can't collect the x squareds and the x's together. They've got to stay separate. So 2x squared minus 7x minus 4. Okay, so here's an inequality. N is an integer. An integer is a whole number. So we need to write down the whole numbers here. So if we think about the whole numbers, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. And let's have a look. From minus 3, now this symbol here is a less than, not a less than or equal to. So that means minus 3 is not included. So minus 3 is not included, and anything smaller than minus 3 doesn't count. So minus 3 is smaller than n. So our n could be minus 2, could be minus 1, and then we go all the way up to 1, and we include 1. So we can cross these ones out. So our final answer would be minus 2, minus 1, 0, and 1. Part B, if you remember, the way to deal with this is to just take that little inequality sign and change it into an equal sign, and then work from there. So something, take away 7 is 11, so that something has to be 18. So before we took away the 7, we had 18. So that means that this something here that we put a circle around, or that we put our finger over, that is 3p. So 3 times p is 18, so that means that p would have been 6. And then at the very end of the question, we must put that inequality sign back in. So p inequality sign 6. Now if you want, you can put that inequality sign all the way through. Instead of these equal signs, we could have written greater than, greater than, greater than. But final answer, p is greater than 6, and that will get us 2 marks. Next one then, so this is a right angle triangle, and they give us the length of 2 of the sides, and we need to find the third side. So that is a Pythagoras theorem question. First thing with Pythagoras theorem is draw the squares on. You might not have room, so just go off the edge of the page if necessary, or just draw the diagram out again, including the squares. And if you remember, with Pythagoras theorem, what we say is that the area of the small square and the area of the medium-sized square equals the area of the big square. So the area of this small square here is 6 times 6, that's 36 centimetres squared. The area of this big square here is 13 times 13, so that's 169 centimetres squared. So that means that 36 plus something is 169. In other words, this area here is 169, take away 36. Remember to get that the right way around. The little square plus the medium-sized square equals the big square. So 169 take away 36, well, we could do that with or without a calculator. I'm just feeling in the mood to just check this one. So 9 take away 6 is 3, 6 take away 3 is 3, and 1 take away 0 is 0. 169 take away 36. Oh, sorry, 1 take away 0 is 0. Oh, my dear. Right, 133. So the square root of 133 is going to have to go into the calculator. Square root 133. And what I'm getting from the calculator is 11.5325629, but the question says give your answer to 3 significant figures. So I count 1, 2, 3 significant figures, put a line down. This number here is a 3, so I'll leave the 5 alone. I don't round it up, so I get 11.5 as my final answer. Now this next one here, this looks very similar. We've got a right angle triangle, they tell us 2 of the sides, but they ask us to find the angle RPQ. So that is from R to P to Q, so that's this angle here. Now, we haven't covered finding angles of right angle triangles in this year. If you have looked at the top 40 and taught yourself the trigonometry sections, then you may be able to have a go at this, but most of us, we'd leave this one out. There's an awful lot we can do on this paper, so it's taken quite a long time, this video, isn't it? So, okay, question 14. A equals 4BC. Again, we've maybe not done specifically this sort of question, but it's something we can certainly have a go at. We know that in algebra, if there's no symbol, it means times, doesn't it? So that means A is 4 times B times C, and it tells us that A is 100 and B is 2. So if we put that in 100 instead of a capital A, 4 times 2 times C. Now that much might get us a mark. If it doesn't get us all the way, then we're close to 1 mark out of 2. 4 times 2 is 8. 8 times C we write as 8C. And then to solve this equation here, we divide by 8 on both sides. So C is 100 divided by 8. And again, we could use a calculator, or we could cancel the fraction down. So that's 50 over 4. So that's 25 over 2, so that C is 12.5. Part B, we're going to miss that, haven't looked at that this year. Next question. Now, this question is an interesting one. It comes quite a long way through the paper. By this point, we're usually running out of things that we can actually do, and we certainly can't do part B of this question. That requires some grade A material that we've not covered, but part A, we can do. It just says find the area of the trapezium QRST. So Q to R to S to T. So this trapezium here that I've just sort of scribbled on in red. So what we could do is draw that out separately. And it's a bit of an odd one because we like the trapeziums the other way up. If you remember, a trapezium has one pair of parallel sides, and that's these parallel sides here. And we'd normally draw the trapezium this way round with the parallel sides at the top and the bottom, but we don't have to. And if you remember, what we do for a trapezium is we add the parallel sides together, 4 plus 12, and then we half the answer. So 4 plus 12 is 16. We half the answer, that's 8, and then once we got that number, we times it by this distance between the parallel sides, which sometimes we call the height. So 8t is the answer that we're looking for there. Next question. Question 16. Now, this is where we're getting very much into the sort of dotted questions. These ones that I wouldn't expect everyone to be able to do, but we can get some of the way. So, Derek buys a house for £150,000. He sells a house for £154,500. So the profit is £4,500. Now it says work out the percentage profit. So we need to work out 4,500 as a percentage of 150,000. So we do 4,500 divided by 150,000, and then stick that in your calculator, whatever comes out, times the answer by 100, and there you have the percentage. Now, part B, this isn't something we've done this year. It's not on the top 40. I wouldn't expect most people to be able to do it, but we did do it in year 10, and you may remember it from then, and also it's something that we might be able to get some marks on. So it's 4% per year compound interest. Now what that means is, so it works like this, £154,500. After 1 year, we're going to have £154,500 and an extra 4% of that, so we add on 4%. After the second year, we find 4% of the amount that we have after the first year, and then we add on 4% of that. So it's adding interest on the interest. Now, if this isn't making sense so far, my advice is ignore it, skip straight past this question. You don't need this in order to be able to get to a grade C, but perhaps for those people who are on a C already and you're looking to try and get grade B, then you might want to have a think about compound interest. So £154,500, well, to find 4%, we divide by 100 and then times by 4. Now, if you think about it, finding I'm going to show you the proper way of doing this. You can use this as an example if you want, or you can just miss it out. It's not needed for a grade C. If we're increasing this by 4%, what we're looking for is 104%. So that would mean divide by 100 and times by 104. Okay, so in other words, 154,500 times by 1.04. So if we're increasing something by 4%, it's the same as timesing by 1.04. Now we're doing this for 2 years, so we're going to times by 1.04 twice. So 154,500 times 1.04 times 1.04. In other words, 154,500 times 1.04 squared, but however you want to type it in your calculator, that's one way of getting the answers. Again, don't worry if that doesn't make sense. That's just for those people who maybe remember it a little bit from last year. Maybe you're already getting solid C's and are looking for a grade B. Now, this one is a very interesting one. This is something we can do because it just asks us to use our calculator. We haven't looked at, or some of us have, the ones that, anybody that's looked up the trigonometry stuff on the top 40, you might have seen this tan button on your calculator, but that's fine. It says calculate the value of, and it says write down all the figures in your calculator display. So that means you just got to find the stuff on your calculator. Now, if you look on your calculator, there'll be a button that says tan on it. So if you type in tan, and then you type in the number 60, and then you press equals, you should get this number out, 0.3200403894, or something along those lines. So 3200, that's a 4 there, isn't it? If we add 1 to that, so that's tan of 60, then add 1. So we'll add 1, and we're going to get 1.3200438894. If we take away 1 from that, so we're going to get that on the top, divided by, 0.3200438894, take away 1. In order to do that, we're going to have to go back to our calculator. So I'm going tan of 60 degrees, tan 60 degrees, and I'm taking away, take away 1, and I'm getting minus 0.67995. Oh, I've just realised, if you're following this question, we're going to have to start the whole thing again. I've made a mistake here. I've got my calculator in the wrong mode, which reminds me to warn you to not make the same mistake. So just have a look on your calculator. Somewhere on the top line, there will be a little D. If that number is a little r, then that means you need to change it. Come and see me in lesson and I'll change it to a D for you. So let's start again. Don't worry about what all this stuff means for the moment. We just need to see if we can find this the way through this question. So let's start again. If we type in the tan button and then we press the number 60, what we actually get is 1.732050808. So if we add 1 to that, we get 2 point blah 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 blah. If we take away 1, we get 0.732050808. And what this asks us to do is tan of 60 plus 1 divided by tan of 60, take away 1, and then square root the whole thing. So in my calculator, I'm just going to type that in. I'm going to type this number in the calculator, and then divide button, and then this number, and let's see what we get. So that is 2.732050808 divided by 0.732050808. The number I've got out is 3.732050806, and then we need to take the square root of that number. Now, this might seem like a lot of hassle, but the whole point here is that it's worth doing this very carefully. It's worth 2 marks, look. It's worth 2 marks. So for 2 marks, we can afford to spend a few minutes typing things in a calculator, typing them in carefully, even if you're not quite sure what everything means in this question. Have a go anyway. We're not sure what this tan 60 thing means, but there is a tan button on your calculator. We may as well spend a couple of minutes of the exam typing this in and seeing what happens. Now, don't do that if there's still other stuff that you think you can definitely get right. So if there's questions of things that we've covered, then do those first of all. But if you've got spare time, and a lot of people will have in the exam, then give this a go, see what you can get. So it says in the question, write down all the figures in your calculator display. When I do the square root of this 3.732050806, I'm getting 1.93185165 And there's our answer. Okay. Last question we can do on this paper then. And you'll have noticed there's a lot of questions we can do on this paper. Some of them trickier than others. A lot of them not straightforward, but this is what we're looking for. Now, it's asked us to draw a box plot, and if you look at the next part of this question, it gives us a reminder here of exactly what a box plot looks like. And if you remember, this here is the lowest value, this here is the highest value, this is the lower quartile, the median, and the upper quartile. Now there's 3 marks, so even if you can't remember about lower quartiles and upper quartiles, you will get 2 marks out of 3 if you get the highest value, the lowest value, and the median plotted properly. So the lowest value is 5 and the highest value is 44. So 5 halfway between 0 and 10. So I was saying that because we always have to check the scale. Here's 40, here's 50. So each little square is just one number. So 41, 2, 3, 4. You have to be accurate. It has to be exactly in the right place, not close to it. So we've got 5 and we've got 44 plotted. Now we want the median. So the way that we find the median is we cross off from both sides until we reach the middle. I'm not actually crossing through the numbers because I'm going to want to be able to see them in a minute, but I'm still working my way towards the median, and we've got a 25 left in the middle. So there is my median, 25, and I'll mark 25 on my box plot just here. There we go. Okay, now we need the lower quartile and the upper quartile. Now if you remember, quartiles are about taking the data and splitting it into quarters. So if we have a look here, if I put a circle around the 4 there, and the circle around the 14 and there's another circle around the 30, we've got 3 numbers here, then the lower quartile, 3 numbers here, then the median, 3 numbers here, then the upper quartile, and then sort of 3 numbers at the end. Now we can't split this thing up any more neatly than that. We're going to end up with we're going to end up with things sort of slightly. So that is perfect, isn't it? We've got 3 numbers, 3 numbers, 3 numbers, and 3 numbers. So everything sort of turned out nicely. We've split it up nicely up into 4 different sections. If you want a little bit of a trick for that, you could think of it as find the median, and then the lower quartile here. Look, is if we crossed off the whole of the top of this list. Oh, don't cross the median off though. Sorry, if you cross everything off above the median. No, sorry, do cross the median off. There we go. If we cross off everything there, then the median of this lot here is the lower quartile, and the other way around it works as well. If you think of the top half of the list, there's the median. Cross off everything up to the median, and the upper quartile is the median of that bit there. Now, I know that's a bit tricky. I know it's perhaps not that easy to follow, and I know that we haven't done it in great detail in lessons. We have talked about lower quartiles and upper quartiles, and how the lower quartile is the quarter of the data, and the upper quartile is the top quarter of the data. It doesn't really matter if you don't get all the details here. There's 3 marks for this question. If you can get 2, then that should be plenty for us, because we've got plenty of marks to get a grade C. Okay, so perhaps this one could have had dotted lines around it, because we can get 2 marks out of 3. But you can get 2 marks out of 3 for putting on the lowest piece of data here, the highest piece of data here, and the median here. And if you can get the quartiles right, then there's a bonus mark for us. Now, compare the distribution times that people went to Rose's Garden Centre and the distribution times people went to Green's Garden Centre. So now we have to make sure we've actually read the question, and we can see the box plot that we had to do tells us about Rose's Garden Centre, and the other one asks us about Green's Garden Centre. Now, when it asks you to compare these things, there's 3 things you can compare. You can compare the range, you can compare the interquartile range, which is the upper quartile take away the lower quartile, and you can compare the medians. So you would want to say, in this case, let's have a look. The median is higher at Rose's than at Green's. You'd want to say that the range, well, we'd actually have to calculate it, but I can see here, look, the range goes from 55 to 14, and here the range goes from 44 to 15. So the range is bigger at Green's Garden Centre, and the interquartile range, if we look at it on here, is this distance here, so from 30 to 14, and over here it's 35 to 12, so the interquartile range is bigger at Green's. So I would just write it down like this: the range is bigger at Rose's, the interquartile range, and the median was bigger at Rose's, wasn't it? My fault. The median was bigger at Rose's, the interquartile range and the range were bigger at Green's. Okay. Now, if you look at this question, there are 2 marks for it. That will get us 1 mark. In a lot of papers, it will get us 2. Sometimes for this question, though, they are a bit horrible, and they say that you've got to make one of those comparisons in context. So let's have a look at what the question says. It is asking us about how long it took for people to be served, how long people waited to be served. So we could look at the medians and say that on average, people waited more time to be served at Rose's Garden Centre. And so we just need to put that comment in context. So if the median is bigger at Rose's, that means that on average people waited longer at Rose's. You can't say people waited longer, you need to say that on average they waited longer, because not every person waited longer necessarily. If you look at it, the shortest wait time down here is actually smaller at Rose's Garden Centre than it was at Green's Garden Centre. So we've got to be a bit careful there. You can't just say they waited longer. If you say they waited longer on average, that will do. But make sure that you write down these 3 comparisons every time you get that question. And if you can then make one of them in context as well, that's full marks. Okay, so a lot of stuff on that paper, a lot of it quite tricky. Remember, we're aiming at 30-ish marks for a C. I think it was 32 or 33 on this paper, and we have about 60 marks to go for. So make sure you can do everything in the top 40. There's a lot on that paper which we could maybe do, which we can have a stab at, which was a bit tricky, but as long as you can do the stuff that's on the top 40, then that will do, and the other stuff is bonus marks.